Assalamualaikum and hi. Alright, so today we're going to learn about a nodal analysis and then we're going to implement in this figure and these questions. Right, the example and answers is already for you to double check is it your answer is correct or not. The question is we need to compute V1 and V2 in this circuit using a nodal analysis. Right. So this circuit is already in phasor domain, right? Phasor domain. So you can see here the capacitor already in impedance, the inductor also already in impedance. And then a good news for you, right? The node voltages, okay, V1 and V2 already assigned for you, plus the ground here. So now our job is to implement nodal analysis in this figure. So let's look here. Alright, so we have a voltage source 1045 degree in the middles of node voltages, right? And then we have the element 4 ohm which is in parallel of 10 and 45 degree. So since this voltage in the middle of node voltages, okay, I can say the 10, 45 degree and the 4 ohms are supernodes. Okay, are the supernodes. Okay, since this is a supernode, we need do analysis a little bit different from the original of nodal analysis. Now let's do it, right? Let's do it. Okay, again and again we need to assign all the current out, right? All the current out from the nodes. So here, so let's write the equation of supernode. What is our supernode equation? I start from here. So this is minus 3, right? Minus 3, and then here is plus V1 divided by minus J3, and then here this part plus V2 divided by J6, and here this part plus V2 divided by 12 equals to 0. And then we need to consider the KVL equation, this part, right? This part. What the KVL equation, this part? KVL equation in this part is minus V1, right? Minus V1 plus 10 45 degree and then plus V2 equals to 0. And then later on we need to simplify this equation. We need to simplify the equation. So I basically group one part for V1 and V2 because we are going to use a Cramer's rule. So for example, in this supernode equations, it becomes V1, right? 1 divided by minus J3 plus V2, 1 divided by J10, and then plus 1 divided by 12 equals to 3. This 3 is come out from here. And then we can rearrange for the KVL equation is minus V1 plus V2 equals to minus 7.07 minus J 7.07. Right, this part actually from here 1045 degree. When we change from the left hand side to right hand side, I think it's good for us to use a rectangular because we must aware the signs of positive and also negative. That's why I use a rectangular. So then we need to fill in all the equations in Cramer's rule. So we need to form in metric, right? From the equations from the equation we obtain 1 minus j3 1 j6 plus 1 12. So minus 1 here, and then here 1. Alright, so here is v1 v2 equals to 3, and then here is wow, so messy, right? So here is minus 7.07 minus j 0.07. Alright, so the next step, you need to find the determinants, right? The determinants, and then you need to find v1. How can we calculate the v1? v1 is, we need to change this part, right? This part into the first column. So it becomes 3 minus 7.07 minus j 0.07, and then maintain this part 1 j6 plus 12 1, and then we need to divide everything into determinants. Yes guys, you need to work out how to find the value of the determinant, and you need to work out how to find the value of v1. So very simple for v2. Okay, very simple for v2. For v2 we just use previous KVL equation. Just use previous KVL equation. Okay, still remember, if you obtain the value of v1 here, okay, what is your value here? We just use minus v1 plus v2 equals to minus 707 minus j 7.07. Okay, let's say you know what is the value of v1. Okay, v1, so v2 equals to minus 7.07 minus j 7.07, okay, this part plus v1. Then finally, you know what is the value of v2. So yes, of course, you need to work out, you need to calculate, and then use your calculator properly, and then I believe, yes, you can obtain this answer. Okay, until here, see you again. Bye.